Right, okay, short date and learn objective, please. And then we'll get on with the lesson. Right, okay, so as we can see, inverse of linear functions. So inverse means the opposite. Okay, inverse means the opposite. So going back to stuff you might have done when you were sort of in year 6. So if that times 3 plus 4 equals 19. Now, in order to find this, I work backwards. And when I work backwards, I do the opposite function. So if I was just to swap this question around, it would become 19 is equal to, and instead of plusing 4, I'm going to take away 4, okay? And instead of timesing 3, I'm going to divide by 3. And then it should give me my answer here, okay? So, 19, okay? So 19 take away 4 is 15, divided by 3 is 5, okay? 5 times 3 is 15, yeah. So working the opposite way, when you work in the opposite way, you do the opposite sign, okay? So this becomes a minus 4, this becomes a divided by 3, and so on, okay? I know you can kind of work that out in your head anyway, but obviously when you get to more complicated questions, let's look at this one. So if I wanted to find that, divided by 5, take away 3 equals 37. So what I'm going to do, I'm going to go in the opposite direction. Instead of taking away 3, I'm going to add 3, so that gives me 40. Okay. And instead, in fact, this meant to be a times, didn't it? Okay. And instead of timesing by 5, here, I'm going to divide 40 by 5. 40 divided by 5. So it gives me 8. Let me just check. 8 times 5 is 40. Take away 3, 37, yes. So it's where you go in the opposite direction and you do the opposite, and then you do the opposite calculations. So again, this sum becomes, sorry, I did a plus 3 there, and I did a divide by 5, so it becomes 37 plus 3 divided by 5 equals 8. And I've done the inverse there, okay, the inverse. So when I'm going the opposite direction, I do the opposite calculation, okay. Let's just do one more, because I've got one ready. Plus 3 divided by 7 equals 4. So I'm going to go here, instead of dividing, I'm going to times, so it becomes 28. Instead of adding, I'm going to subtract, okay, minus 3, and that becomes 25. Yeah, 25 plus 3 is 28 divided by, yeah, okay. So, inverse linear functions. So we can do the same then for a linear function. So let's have a look. We've got for a linear equation, sorry. Y is equal to 4x. Now this, remember, this means y is equal to 4 times x. So if I want to do the inverse, the opposite, I'm just going to work in the opposite direction. So instead of x times 4, I do an x divide 4. So y equals x over 4. Okay, so the inverse function of y equals x 4x is y equals 4 over x. Okay, it's the opposite operations as we're going through it. Okay, let's go through another one. So we've got y is equal to x plus 7. If I want to find the inverse of this linear equation, the inverse of it, I'm just going to do the opposite. So I'm going to work backwards. Instead of adding 7, I'm going to subtract 7. Okay, x stays the same. Okay, so y is equal to x take away 7. These are inverse function, the inverse of each other. Okay, we could have y is equal to x over 3. So again, y equals x over 3. This is x divided by 3. The opposite of dividing is times, so it becomes 3 times x, isn't it? So y equals 3x. Instead of x divided by 3, it becomes 3 times x, 3x. Okay, these are the inverse of each other, the inverse. Sorry, I've jumped ahead a little bit. You'll notice when you go through this in the textbook, they do show you we're using function machines. If you want to use the function machines like they show you, you can. I personally find them a bit confusing. Okay, let's have a look at this one. So y equals minus 2x, y equals minus 2x. Okay, so again, I want to do the opposite. It's x times minus 2, but this minus 2 will stay the same. So it becomes x divided by minus 2. Okay, so that's what we got on that one. Okay, and the same again if we have y is equal to minus x plus 4. Okay, again we're going to turn this plus 4 into a minus 4, but this minus x actually does stay the same on this one. Okay, we don't change the value of that. Okay, so y equals minus x minus 4. Okay, they are the inverse of each other. Right, could you please page 236, page 236, could you just do, if I was going to get us to do question 1 as well, but we won't bother with that now. Let's just do question 5, please. Do question 5. When you've done those, we will move on to the next part of the lesson. Okay, so pause the video, just start with those, please. If you're not too sure, actually you can as well if you want to do question 1, but that's optional. Maybe have a little look at question 1 so you can understand it. Okay, right, pause the video while you do those and then we'll carry on. Right, okay, so now carrying on, if you've got 2x plus 6, okay, so there's our linear equation. So again, if we want to find the inverse of this, we're just going to do that minus 6, and then we got x, and we divide it, and we actually put all of it over 2. Okay, we put the whole, we put the over 2. Okay, so this is what the inverse of that is. Okay, that's the inverse. Okay, so we got we're going backwards, but we make sure we put the whole of this expression over 2. Okay, right. Another example of this would be y is equal to x, take away 2 over 3. And again, we're going to do the opposite. We're going to do the opposite. So this minus 2 is going to become a plus 2. Okay, I'll just do it underneath. It will become a plus 2. And instead of x divided by 3, it's 3 times x, 3x. Y equals 3x plus 2. Doing the inverse, doing the opposite. Okay, the inverse. Now, it starts getting a little bit odd when brackets are involved, and I found this pretty odd. I was speaking to my son about it, and he was saying that after today, really, you'll only use these mainly with the calculators, so we'll get easy then. So let's have a look at this one. Have a go at that one yourself, please. Have a go. Just write it somewhere in your book, go in the corner anywhere, scrap piece of paper. Have a go at that one. Pause the video a moment, and then we'll go through it. Right, so to find the inverse function of this, okay, it's not what you'd expect, because my first thought was, oh yeah, you expand the brackets, but actually no, you don't. So you just work our way backwards again. So this minus 2 becomes a plus 2, yeah. And then when we come to this part, again, it's x times 3, and we're only going to put, so it's 3 times x, so we're going to do the other way around, x over 3. So you only actually have the x divided by 3, and then you have your other integers separate. Okay, so that's how you do those ones. Let's have a look at another one. Let's have a look at another one, because they are a little bit confusing. And again, so what we must remember, we don't expand the brackets with these ones. We just work backwards, and we call this a -3. And then we're just going to do, instead of x times 4, we're going to do 4 divided by, x divided by 4, isn't it? We do the opposite, the inverse operation. Okay, and that's what we get for that one. Let's have a look at this one. How would you think, and have a little go at this one yourself, okay? Y is equal to x over 5 plus 4. Have a go at that yourself. Just pause the video a moment and have a go at that. Right, let's have a little look. So again, remember, we're working in the opposite direction because we're doing the inverse. So this becomes a -4. Now remember last time when we did the with the brackets, isn't it? Okay, so in this case we actually have to put the brackets back in, because it's yeah, so it becomes 5x like that. Y equals 5x minus 4. So with these, when you're only dividing it by the one number, you put the bracket in. Now that is different to x, let's have a look at this one, x minus 2 over 3. On this one, we do just 3 times the x is 3x, sorry, y equals, okay. So then this one becomes y is equal to 3 times the x is the 3x, and instead of the takeaway 2, we add the 2. So you can see the difference between these two questions here, okay. Here when you've got this expression all over 3, okay, you don't put the brackets in, but when you've just got x over the single integer, then you put the brackets in, okay. You put the brackets in, so it's a little bit awkward, okay, a little bit awkward. Could you have a go, please, at question 6, please? Question 6 in the book. So again, page 236, page 236. Really, I would like you to sort of, sorry, I should have mentioned this last time, so write out the original. 3 equals 3x plus 7, and then you can write the inverse either to the side here or underneath. I probably generally work it downwards, minus 7, and then we know that's going to be x over 3 like that, isn't it? Okay, so finish off 6, please. Just 6 questions. Some of you will zoom through this quite quickly, others maybe just take a little bit more care. Just remembering the trickier ones with the brackets, okay. Pause the video while you do that, then we'll move on to the next stage. Now I want us to have a little look. Let's have a little read of the investigation, please. The investigation which is underneath, and this is kind of, I would suggest this is the main part of the lesson really. So the investigation, plot the graphs y equals 3x and its inverse function on a set of axes. So I'm going to just do that for you now, okay. So we've got here, so it's asking us first of all to plot y equals 3x. I'll just write that, y equals 3x. So it's telling me here I've got nothing in, there's no c, okay. So that tells me that it will be going through the origin, isn't it? The y-intercept is the origin when there's no number there. So 3x, that means, so the gradient is 3, the gradient is 3, so that's for every 1 across, there's 3 up. So if I want 1 across, 3 up, I would get here, wouldn't I? Okay, so this is going to be my first point, there to there, then I go 1 across and 3 up to there, and then from here 1 across and 3 up. So from there I have my first line. Let's just draw that in, okay. I've drawn that's my this is my line for this equation, y equals 3x. Now it's asking for us then to do its inverse function. So let's do the inverse function first. So y is equal to 3x. So that becomes instead of that, I'm going to do y is equal to x over 3, isn't it? Okay, x over 3. So that is that's my inverse here. So that means I have to do this one next. Okay, so x over 3, so that'll be for every one I go across, again, it's going through the, I know it's going through the origin, okay, because it has no other, it's nothing after it, there's no c, there's no y-intercept. So in order to find this, so it's x divided by 3, so that means 1 across the x will give me a third going up, okay, a third going up. 1 across the x, another third, one across the x, another third. So it would take me to that, isn't it? Okay, because my gradient here is a third, basically, isn't it? Okay, so again, I go here, so I'm going to go 3 across, 1 down, there, and I draw my line in. Okay, so I've got my 2 lines, I've done my original one, and now this is the inverse. This is the inverse of it, okay? So this is y is equal to x over 3, okay? So leave this now. Right, so I've drawn those 2 lines on there. It's asking next, these graphs are a reflection of each other. Draw a mirror line, draw in a mirror line, okay? So I'm going to draw in the mirror line. Let's just grab a different color pen. So I'm drawing my mirror line. So mirror line means it has to be equidistant, isn't it? Okay, so let's have a look from there to there. That would be a mirror line, okay? From there, oh, it hasn't quite reached there. But, so that will be there. This is equidistance there. Again, here I've got 1, 2, 1.5, 1.5 to there. So let's draw that in, okay? So that's our mirror line. Okay. So you can see, if this is our mirror line, I'll just move it around a little bit. You probably can't see it, maybe if I move it this side. Might be easier. Okay. If we look at this part here, we can see this is a mirror line of these 2 lines, okay? In fact, it's fairly accurate, okay? It's not good. Yeah, it's gone from there to there to there, okay? It's not perfectly drawn. So what I've got here is a mirror line between them, okay? And you can see this, and what's it asking next? What is the equation of the mirror line? The equation of this mirror line is x is equal to y, isn't it? Because 1x is equal to 1y. So this is x equals y in our mirror line. And actually, this is what you will find. I want you to finish off the investigation. Okay, I want you to finish off the investigation. This is what you will find is that the graph of an inverse function is a reflection of the original function in the line y equals x. Sorry. No, it doesn't make any difference. Y is equal to x. So when you finish these off and draw in your mirror lines will always be y equals x, okay? Y equals x. But I haven't said that. It could be involved negative numbers, but I'm not too sure. Right, so that's the beginning of the investigation. What I would like you to do, please, is to finish the investigation. Okay, finish that investigation. As I say, it's just there. Have a little look back on it if you're not too sure. After you've done the investigation, depending on how much time you've got, use up all the time, please, okay? If you're feeling just quite confident, just go into the strengthen questions, okay? And actually, they're not too tricky. And they should, that's just going to sort of, it's a little bit more of what we've been doing. If you're feeling very confident on this work, and you know who you are, who needs to be pushed hard, finish off the page, questions 7 and 8, a couple of tricky questions there. And then there's some additional extension questions. So try and get as much done as you can with these extension questions. I'm not sure how long the rest of the lesson will take, that's all. But good luck with that, okay? Go back and have a little look at the video if you're not too sure. Okay, right, good luck, bye.